Okay, so we're going to use a lot of chemical formulas in this unit, and so we need to understand kind of how they look and what the different parts mean. Okay, so first thing remember is that every capital letter will start a new element. So if you check this one out, I've got several capital letters, right? I have capital N, capital C, and I have a capital O. Okay, this tells me that I have 3 different elements in here. Okay, I have the N, I have the C, and I have the O. Now, what it doesn't tell me is it doesn't tell me what this little A goes with. Okay, I always use the example of a little kid crossing the street. They can't go without their parent, so they get stuck to the one right before it. Okay, so I have 3 different elements that make up this chemical formula. All right, now I will never make you memorize what these all mean. You may use them often enough that you start to remember them, but remember, I'm always going to give you this periodic table. Okay, so you can use this periodic table and you can find things on here and tell me what they actually stand for. So Na, if I come over here, okay, Na stands for sodium. Okay, the capital C stands for carbon. And the O is oxygen. And like I said, some of these you will just use them often enough that you'll start to memorize them. Okay, but I will always give you a periodic table, and that's totally fine. Okay, so when we're reading a formula, every capital letter means that I have a new element that is starting. Okay, all right, good. So this is what this means. Now, the next thing that we're going to look at are these little tiny numbers that are kind of squeezed in between things. Okay, these are what we call a subscript. Okay, sub as in like below, like a submarine is below the water, a subway is underground. Okay, so this is just what we call a subscript. Okay, so this number right here, okay, is a number 2. And this little 2 tells me how many of this thing that I need. Okay, so it always is what comes, like it follows what it's coming after. So it tells me that I have 2 of these sodiums. Okay, that's all it tells me. Now, check this out. Beside my capital C, I don't have a number. Okay, scientists are super lazy. And so if they don't give you a number right beside it, you automatically assume that it's number 1. Okay, because if it was really 0, they wouldn't have even written it at all. Okay, so if they don't tell you, it's just 1. Now, please avoid just seeing this 3 and being like, oh, that's 3, because the 3 here only goes with what's right before it, the capital letter right before it. So this 3 only goes with the oxygen. Okay, so it tells you that in this chemical formula, we have 2 sodiums, a carbon, and 3 oxygen. Okay, pretty easy. Okay, if we come down here and we have H3, okay, how many capital letters do I have? Only have 1, and if I use my periodic table, capital H is hydrogen. All right, and then this subscript, or this number down here, tells me how many hydrogens that I need, and it's going to tell me that I need 3 hydrogens. Okay. All right, so this is the very easy version of it. It's not too terrible. But I do want to show you one more thing, just in the off chance that you come across it. Okay, let's say that we'll use H2O. Okay, we'll use water. Okay, a capital letter, a capital letter. So we need to figure out what H stands for and what O stands for. So if I look on my periodic table, capital H is hydrogen. Okay, capital O is oxygen. Okay, and if I'm looking, this 2 tells me that I have 2 hydrogens. and it doesn't tell me how many oxygens I need. Remember, we're lazy, so if they don't tell you, just assume that you have one. Okay. All right, and this is nice and easy. But so let's just draw what this is going to look like. We haven't done that in the other ones. So it's telling me that I need 2 hydrogens and 1 oxygen, and they all need to be stuck together. Two hydrogens, 1 oxygen, and they're all stuck together. Now you can draw it like this, or you can draw it like this. There is a correct way to do it, but as we're in 6th grade, we're going to keep it really simple, and I just need you to show me that they're chemically combined or they're stuck together. Okay? All right, good deal. Now, did you notice that my H's are both capital letters? All right, even over here, they're capital letters. Okay, so make sure your symbols are accurate. But what happens if they put a number in front? Okay, you can tell me about H2O, and so what I will do is I will do that first. Okay, you have your hydrogen, and you've got 2 of them. You've got an oxygen, and you've got 1 of them. And this number out front tells me how many of the whole thing I need. Okay, so if hydrogen and oxygen is 1 water molecule, it's telling me that I need 2 water molecules. Okay, so this number out front just tells me how many of the separate molecules that I have. So what I will always do is I'll kind of cover this up. I'll do this, I'll answer this question, draw it, and then I look and see how many of those molecules that I need. Okay, so this is just kind of the easy version of how to read a chemical formula, kind of like the rules for it. All right, and so I want to do a few examples because students get very they feel like it's super easy, and then they start skipping ahead and they forget to like actually think about what is happening. So the first one we have is NaCl. Okay, and this is salt. It doesn't matter that you know that, but it is salt. All right, so I will always ask the question, how many capital letters do I have? Okay, in this one, I have 2 capital letters. I have N, and this little lowercase a gets stuck with it. All right, and then I have a capital C. And now check this out. This is a lowercase l. Okay, and so it gets stuck with it. Now, the reason I know it's a lowercase l, because anytime that we're talking in science, if I'm using a capital I, it will look like a capital I. I will be very specific, and I will show it to you because I don't want you to get confused. So if it looks like this, it just means it's a lowercase l. Okay? All right, so the first thing I do is I have Na and I have Cl, and I'm going to use my periodic table, and I'm going to find them on here. All right, so I have sodium for Na. I'm just going to write it down. Okay, Cl, I'm going to look for it on my periodic table. It's over here somewhere. All right, now I'm going to spell it correctly because it tells me how to spell it. Okay, so these are the elements that are inside this chemical formula. All right, so I've got Na and Cl, I've got sodium, and I've got chlorine, and I need to know how many of each element that I'm going to need. So I'm going to look here. Does it tell me a number right here beside this first one? It doesn't. Assume that it's just the number 1. Okay, so I have one atom of sodium. Again, beside my chlorine, it doesn't tell me, so I'm assuming that it is just 1. Okay, so add those 2 together. You get a total of how many atoms? 2 of them. Okay, all right, so when I'm going to model that picture, I just need 2 atoms stuck together, chemically combined, and I'm going to write them NaCl. Okay, my lowercase letters get stuck with the big ones before it. Okay, lowercase gets stuck with the one before it. And now here comes the big question. Is this a picture of an element, molecule, or compound? Okay. Now, so the first question I always ask myself is how many circles do I have here? Because if I have more than one, it cannot be an element. I've got two here. So this is not an element. Okay. A molecule means that I have more than one. So if I have more than one, automatically makes it a molecule. Okay. Now, when I'm talking compounds, compounds are what I call fancy molecules. It just means that it's a molecule, but it's got to have different stuff in it. It's got to have different elements inside of it. So because I have Na, and that's different than Cl, that would make it also a compound. All right, so my answer here is that it is both a molecule and a compound. Okay, so I can read my formula, I can tell you what's in it, I can tell you how many of it, I can draw a picture of it or a model of it, and then I can tell you from that if it's an element, if it's a molecule, or if it's a compound. All right, let's try the next one. All right, because it's got more numbers and it's a little bit crazy. Okay, I always start with the question, how many capital letters do I have? In this case, I have 3. I have the capital H, the capital S, and the capital O. And if I look on my periodic table, H stands for hydrogen, S stands for sulfur, and O is oxygen. All right, good deal. Okay, now I need to know how many of each one that I need. So I'm going to go back and check this out. It tells me that I have 2 hydrogen atoms. Now, again, watch very carefully because a lot of students will look at this and they'll see 4 and they'll automatically assume they get 4 S's and 4 O's. Not true. Okay. With this S, does it give me a number here? It does not, which tells me I'm assuming that I just have one of those. Okay. But this 4 goes with a letter right before it, which goes with my oxygen. So I have 4 oxygen atoms. Okay, add these all up. I have a total of 7 atoms. So I'm going to put 7 circles. And remember, you could put 7 in a straight line. For this, I'm not going to be picky because you're in 6th grade. All right, and it's going to tell me exactly right here what I need to draw. I need 2 hydrogens. Remember, if my H is capital here, it's got to be capital in my model. I need 1 sulfur, and I need 4 oxygens in my picture. Okay, in my model of this zoomed in version of this chemical formula. Okay, so then I'm going to look, is it an element, is it a molecule, or is it a compound? All right, and I like to do this just so I can mark them out. The first question here is always, how many circles do I have here? Because if I have more than one, it cannot be just an element. Okay, I've got more than one, not an element, which means that it has to be a molecule. Okay, all right, now, is it a fancy molecule? Is it what we call a compound? Remember, in order for it to be a compound, it has to have more than one type of element here. And because I have more than one type, I know that it is, in fact, a molecule and a compound. Now, I don't like that I circled these because it looks like another model that I have over here. You can put the check marks if you want. Okay, these are just lots of practice. You guys will have these, and we're going to work through some more of these. So good luck. Let me know if you need any help.